Continuing with section 1.5, solving inequalities, out of our chapter 1 on equations inequalities, we have an exploration now. Recall I said the two big differences in solving inequalities versus equations was 1, how you show your answer, and we just went over that, and 2, this one other thing we have to consider, and the exploration is going to help us remember that. So, true or false, 3 is less than 5. Of course, that is true. Now, multiply each side of the inequality by 2. Do you agree with your true or false statement? All right, 2 times 3 less than 2 times 5. So is 6 less than 10? Yes, I do agree with my original true or false statement. True or false, 3 is less than 5? Yes, of course it is. Now let's multiply both sides by -2. And we have -6 less than -10. Do we agree with that? No, of course not. That is not true. -6 is not less than 10. It is greater than -10. -6 is not less than -10. It is greater than -10. So what have we discovered? We've discovered the multiplication and division properties for inequalities. And just in basic words, that tells us if you multiply or divide, and I'm sure you're remembering this, but it's multiply or divide an inequality by a negative number, what do you have to do? Comma. You must reverse or switch, whatever word you like for that, the inequality sign. So if we go back up here and we switched it to -6 greater than -10, then we would have said yes, right? So that's what we have to remember. Now, in every single inequality you work, are we going to have to multiply or divide by a negative number? No, it's only when you have to do that, okay, that you have to remember that. Sometimes it's not an issue and you don't worry about it. Now, I have seen students work these problems by changing the inequality to an equal sign. That is incorrect. Do not do it. You can't get credit for doing things like that. That is not right. I don't care if you've been shown that previously. Do not do that. We keep our inequality. We know how to solve an inequality. We don't change it to something else. We solve it as it is. Okay, so this is our inequality. Just like an equation, we want to get rid of the parentheses and we want to isolate our variable. So we have 4y plus 10 greater than, distribute 2y minus 6 plus 8y. Simplify the right-hand side, 4y plus 10 greater than, what do we have, 10y minus 6. I like to keep my variable on the left-hand side. If you recall, all of our answers from the first video where we show our answers had x on the left side if it wasn't between two numbers. So you'll avoid mistakes and you'll be able to put it in the correct notation. So I'm going to subtract 10y. -6y plus 10 greater than -6. Subtract 10. -6y greater than -16. And divide both sides by -6. And remember to, and this is the step where you do it. I'm doing that, so I've got to reverse my sign. So I get y is less than 16 over 6, which that's going to simplify, isn't it? They're at least both divisible by 2, so y is less than 8/3. Okay, so now we look at, you can look back if you're not sure, but we have to give our answer in set notation, interval notation, and graph. Set notation, the set of all y. It's okay, it can be y or x or anything. Y less than 8/3. There's set notation. This is an open interval, right? Y is less than 8/3, so it goes from -infinity to 8/3, but doesn't include 8/3. And then we would graph that by just drawing the number line, putting our 8/3 on here. There's a parentheses at 8/3, and we're going to the left. Okay? So we've given our answer in all three formats. Let's see if I can get that straight. There we go. Okay, let's try another one. Solve the inequality. This time we have fractions. As I've always said, I don't like to work the problem with fractions. So the first thing I do is find the LCD, multiply, and get rid of them. The LCD of 3 and 8, what would that be? So 8 would be 8, and then 16, and then 24. So I believe it's 24. So 24 times x minus 4 over 3 plus 3, less than or equal to 24 times x over 8. 3 goes into 24 8 times, leaving 8 times x minus 4 plus 3 times 24. What would that be? 72, less than or equal to, 8 goes into 24 3 times, so I have 3x. Distribute 8x minus 32 plus 72, less than or equal to 3x. 8x, what's that, plus 40? Less than or equal to 3x. Again, I like my, I want my x, because I'm going to have to write it like this. X less than or equal to something, or great, it's going to be less than or equal to. So I need the x on the left side, so I'm going to subtract 3x. I have 5x plus 40 less than or equal to, what's 3x minus 3x? It's 0. Some people just don't want to write anything there. They don't know what to write. It's 0. Okay, subtract 40, 5x less than or equal to negative 40, and then divide by 5. Less than or equal to negative 40 divided by 5, and I get x less than or equal to negative 8. Now, did I have to reverse my sign? I did not. I didn't divide by a negative number, so I'm okay. You don't have to do it every time. The set of all x such that x is less than or equal to negative 8. You can't write, if I had put my x on the other side, you can't write it that way here. You have to have the x first to write it correctly. Okay? You may want to do your graph next. It doesn't matter the order that you do this in. So I could find my negative 8. I know it could be equal to, so that means a bracket, and I'm going to the left because it's less than. And I'm showing you doing the graph next just so you can see. Now look at the interval notation. From left to right, I'm going from negative infinity to negative 8, and there's a bracket. So if you've graphed it correctly, you can easily get the interval notation directly off the graph.